Question number 6 says, fill in the blank. An ordered pair is a or an, and then a drop-down menu. Origin, x-coordinate, solution, y-axis, x-axis, coordinates, or y-coordinate. So an ordered pair is a blank of an equation in two variables if replacing the variables by the coordinates of the ordered pair results in a true statement. Well, at this point in the practice test, we've already looked at what a lot of these options are, so we can go ahead and start eliminating right off the bat. An ordered pair is an origin of an equation in two variables. No, that doesn't sound right. An ordered pair is an x-coordinate of an equation in two variables. No. An ordered pair is a solution of an equation in two variables. Yeah, I think that's what we're talking about here, right? And again, just to kind of reiterate what this question is referring to, an ordered pair, and we now know after having reviewed the previous question, that an ordered pair is, remember, an x comma y. It's a single point on your grid. And what this question is referring to is that ordered pair, a point, is a solution to an equation if we can take this point, plug it into an equation anywhere we see an x and a y, and get a true statement. So, for example, let's say that I give you the point, how about 2 comma 1, and I ask you, is this ordered pair a solution to the equation 3x plus 4y equals 10? Is 2 comma 1 a solution to this equation? Meaning, if we take this x comma y ordered pair, plug it into this equation, will we get a true statement? Well, let's see. Again, we know that the 2 is going to be our x and the 1 will be our y. So let's take this 2 and 1, plug them into this equation. So we'll plug in 2 for x, we'll plug in 1 for y, simplify, clean it up, and see if we get a true statement. So we end up with 3 times x, but again, x is now 2, so we'll plug that in, plus 4 times y, but again, y is going to be positive 1, so we'll plug that in, is equal to 10. Is this true? This is what we are testing. Well, we know when we distribute here, 3 times 2 gives us 6. We can distribute here, 4 times 1 gives us 4. So we end up with 6 plus 4 equals 10. Again, is that true? Well, yeah, of course, because 6 plus 4 is 10. So we end up with the statement 10 equals 10, which is absolutely a true statement. And so we can say that this ordered pair 2 comma 1 is a solution to the equation 3x plus 4y equals 10, because when we substitute the x value and the y value into this equation, we get a true statement. Let's say, just for a counterexample, that we wanted to test the point, how about, let's make it easy on ourselves, 0 and 2, where again, the 0 is our x, and that positive 2 is our y, and let's use the same equation. Let's see, is the point 0, 2 a solution to the equation 3x plus 4y equals 10? Well, again, anywhere we see an x in the equation, we're going to substitute in this 0. Anywhere we see a y in this equation, we're going to substitute in positive 2. So we have 3x, so let's plug in our x value, plus 4y, but we're not going to use the variable y. We're going to plug in the value from our point, so in this case 2 is equal to 10. And cleaning this up, simplifying, we know 3 times 0 when we distribute here goes away, because anything times 0 is 0. Here we can distribute 4 times 2 gives us 8, and so we end up with 8 equals 10. Is that true? Does the number 8 equal the number 10? No, it does not. That is a false statement. And so what we would say is that 0 comma 2 is not a solution to this equation. All right, so see the difference? When an ordered pair is a solution, we get a true statement when we plug it into the equation. When an ordered pair is not a solution, we get a false statement when we plug it into our given equation. In this case, an ordered pair is a solution, and so we select solution and move on to question number 7.